Okay, dear students, let's just start the second chapter on budgeting. After this chapter, actually, we are left with two main areas. One is advanced variance analysis and the performance measurement. In this chapter, if you ask me, so there are a number of things, but extremely important area is the learning curve. What it is, and we'll discuss each and everything. Don't worry at all. Hilo method, previously we have already discussed Hilo method. So we'll not be spending so much time on this. Basically, by using Hilo method, we can separate the semi-variable cost into variable and the fixed cost component. So how do we perform this Hilo method? Cost at a high level of activity minus cost at a low level of activity divided by high level of activity minus low level of activity. It simply gives you the variable cost per unit. Then total cost at activity level minus total variable cost will give you the fixed cost. So basically the main purpose of Hilo method is to separate the semi-variable cost into its components, and the components are variable and fixed cost. What are the advantages of Hilo analysis? The Hilo method is simple to calculate. Agreed. It is easy to understand and easy to use. Disadvantages. It assumes that activity is the only factor affecting cost. It assumes that historical costs reliably predict future cost. It uses only two values, the highest and the lowest. So the result may be distorted due to random variation in these values. So you need to know the disadvantages as well. That can come in a multiple choice question. Okay, now let's discuss the extremely important area of this chapter, and obviously rest of the area we have to discuss as well. That is learning curves. Now, what do you mean by learning curve? It's very simple. Actually, what the concept of learning curve says, if an individual is doing the twice of the previous work, if the individual is doing twice of the previous work, then average time per unit will be reduced. What do you mean by this? For example, units average time required per unit, average time per unit. Then we have total time. Okay. Then we can also calculate incremental units. We can calculate total time. We can even calculate average time per unit. Now, what do you mean by this? Let me explain. Assuming, just an example, okay? Let's say the first unit takes 100 hours to produce. Repeat. The first unit takes, let's say, 100 hours of the labor, obviously, to produce. So I'll take 100 hours here. Total time will be 100 hours. 1 multiplied by 100 is 100. And we are producing how many units? 1 unit. Total time is again 100. Average time per unit is also 100. And let's say learning curve percentage is 80%. Obviously, later on, we will also learn how to calculate this average, how to calculate learning rate. But let me tell you, the main concept is when an individual is going to do the twice of its previous work, then learning curve will apply. So twice of the previous work means if now that unit produces 2 units, which is the double of previous, then learning curve will apply. 80% of 100. Now on average, it takes 80 hours per unit. 2 multiplied by 80, 160. How many incremental units now that individual is producing? Initially, that individual produced 1 unit, now 2. So additional unit is 1. How many incremental, I would say, hours? 1 unit takes 100 hours. 2 units takes 160. So incremental time is 60. Average time per unit is 60. The last 3 columns, they are incremental. Let me repeat. Let's go ahead first. Learning curve will apply when an individual does twice of its previous work. So twice of 2 is 4. Twice of 2 is 4. So now I'm going to apply 80% on this 80 hours. So learning curve will apply when an individual does twice of its previous work. If you take 80% of 80, it is 64. If you take 80% of 80, it is 64. So 4 multiplied by 64. Total time is 256. Now, how many incremental unit we are manufacturing, we are producing? Previously, this individual produced 2 units, now 4. So incremental is 2. How many incremental hours? For 2 units, total time was 160. For 4 units, total time is 256. So the incremental time is 96. Now, average time per unit, 96 divided by 2. I'm getting 48. Now, slowly and gradually, you will get a more understanding. What are we doing? And let me repeat. Learning curve applies when an individual does twice of its previous work. So twice of 4 is now 8. Now apply 80% on this 64. If I apply 80% on this 64, I'll get 51.2. So 51.2 multiplied by 8. 409.6. How many incremental units we are producing? Previously 4, now 8. So incremental units are 4. How many incremental hours? Previously 256, now 409.6. So incremental hours are 153.6. So 153.6 divided by 4. 153.6 divided by 4 gives us 38.4. So the concept of learning curve says when an individual does twice of its previous work, then learning curve applies. So twice of 8 is 16. Now take 80% of 51.2. That is 40.96. So 16 multiplied by 40.96. I'm getting 655.36. How many incremental units we are producing? Previously 8, now 16. So incremental is 8. 409.6 and 655.36. So the difference is 245.76. 245.76 divided by 8, 30.72. So basically, the concept of learning curve says when an individual does the twice of its previous work, then average time per unit will reduce. Basically, when we are increasing the output, then average time per unit is actually reducing. It's like this. Obviously, it cannot become zero, but the main concept is when an individual does the twice of its previous work, then learning curve applies. So as the output increases, average time per unit will reduce. If you ask me the total time, so obviously the total time will increase. You increase the output, total time will increase, and it is happening. So we are not, it start from the origin, of course. Total time will keep increasing. So obviously, when you increase the output, your total time will increase. So the main concept is when an individual does the twice of the previous work, learning curve applies. Obviously, over the period of time when you're doing the same work again and again, you will become more efficient. You will be doing the same work in a much more better way in a less time. That is simply the learning curve effect. But a very important point is there are limitations in the learning curve model as well, which you need to know. Limitations. So what are the limitations of learning curve model, of the learning curve model? Number one is the process is labor intensive, which is not happening nowadays. The process is actually, we are assuming the process is labor intensive, which is not the case nowadays. Actually, nowadays we know that manufacturing process is capital intensive. There are too much machinery, technologies involved, rather than the involvement of the labor. So that's a limitation of learning curve model. Logically, the learning curve model is more suitable when the process is labor intensive, but which is not the case nowadays. Okay. Another thing is actually now what is happening when you are doing the same work again and again. So you'll be performing the same work in a better way, in a more efficient way. Another limitation is the product is new. Let's say in a modern environment, the products they are having a short life. So it means on a regular basis, you will be producing the new product. If on a regular basis you are producing the new product, so how can you have the effect of learning curve? There will be no effect of the learning curve. So basically, in a modern manufacturing environment, the life of the product is very short. So all the time, laborers they are involved in producing the new products. So if all the time you're involved in producing the new product, so there will be no learning curve effect. Another thing is the product is complex nowadays. It's not so simple. The product is complex. So basically, what is happening? Actually, the point is the production process of the product is complex. So to a certain extent, learning curve will give you the benefit, but not beyond that. Because of the production process is very complex. Another thing, another limitation is production is repetitive and there's no breaks in production. So learning curve will be effective if production is repetitive and there are no breaks in the production. If there are breaks in the production, then there will be no, then utility of learning curve will be very limited. So production is repetitive and there are no breaks in production. Basically, learning curve assumes that the production is repetitive and there are no major breaks. Obviously, there are no major breaks in which learning effects may be lost. If there are major breaks, then obviously you will not be having a benefit from the learning curve. For example, if an organization is working on JIT production, then obviously it becomes very difficult to get the benefit from this learning curve, because in JIT process, there will be breaks as well. Production will only be carried out when there's a readily demand available. So actually, there are limitations in the learning curve. It does not mean that there's no benefit of the learning curve is still there, but you need to know the limitations. Actually, learning curve is more beneficial when the environment is labor intensive, but nowadays it is not the case. Nowadays, the involvement of the machine and technology is too much. Another limitation is the product is new. In a modern manufacturing environment, products are having a short life cycle. In a short life cycle, every time laborers they are involved in manufacturing, producing the new product, which again limits the effectiveness of the learning curve. The product is complex, which means a very limited benefit you can get from the learning curve, not a really big benefit. Another thing is learning curve assumes that production is repetitive and there's no breaks in the production. Obviously, there are major breaks in the production, so you will lost the benefit of the learning curve. For example, just an example, okay? Let's say if you are just an example, let's say you are learning a new skill. If you're learning a new skill, you took a class today and then you're taking second class after 2 months. So you will never have a learning curve effect at all because there are too much breaks. So these are the limitations of the learning curve, which you need to know. Another thing is, which we have numerically discussed, what was that? We discussed that when an individual does the twice of its previous work, then learning curve applies. Now the question is, what if the individual produces 5 units? Practically, when an individual manufactures 5 units, definitely learning curve will apply. But the approach which we have discussed just right now, it was entirely depend on one concept. The concept is when an individual does twice of the previous work, then we have seen the effect of the learning curve. Now the question arises, what if we manufacture 3 units? What if we manufacture 5 units, 7 units? So whatever the learning curve effect. If this is the case that someone is manufacturing 5 units, of course, learning curve is there, but manually we cannot deal. Manually, we can only deal when individual is doing twice of the previous work. So what is the solution? When someone is manufacturing 5 units, 7 units, or 9 units, then the solution is we have to go for an algebraic approach. We need to use a formula. The formula is y is equal to a multiply by x, the power is b. So let me write like this, a x, the power is b. Now, what is x? X is the cumulative number of units. And this formula will be given to you in exam as well. Cumulative number of units. What is y? Y is the cumulative average time per unit to produce x unit. Cumulative average time per unit to produce X units. Small a, time required to produce the first unit of output. Time required to produce the first unit of output. B is the index of learning. Index of learning, which is equal to log R upon log 2, where R is the learning rate. R is the learning rate. So R is the learning rate, which will be given in decimal. Learning rate expressed as a decimal. Expressed as a decimal. Okay. Now, how we are going to utilize this formula number 1? Number 2, if we don't know the learning rate, then what to do? How to calculate the learning rate? And how we are going to utilize this formula on the spreadsheet. So all these things we are going to discuss in the next class. So in the next class is going to be extremely important, in which we will learn the entire application of the learning curve formula. If learning rate is not given, how to calculate and how to solve this learning curve equation on the spreadsheet. So the coming class is extremely important. Inshallah, in the coming class, we'll complete this learning curve. So thank you very much, students, watching this lecture.